Your car is probably running at about 85% of its potential right now. Not because of some conspiracy, but because modern vehicles are designed for the average driver who might skip maintenance, use questionable fuel, and never read the owner's manual. I'm a certified master technician with 15 years in the industry, and today I'm showing you 15 proven manufacturer-tested techniques that can restore your car's performance safely and legally. No gimmicks, no dangerous hacks, just real automotive science that works. The best part? Most of these take under 10 minutes and cost less than a tank of gas. By the end of this video, you'll understand your engine better than most dealership service writers. Let's get into it. Electronic resets and calibrations. Let's start with the easiest wins. Electronic resets that take literally 60 seconds. Technique number 1, the throttle body adaptation reset. Modern cars use drive-by-wire throttle systems. There's no cable connecting your gas pedal to the engine, just sensors and motors. Over time, your car's computer learns your driving habits and can develop what engineers call throttle position adaptation. Here's what's actually happening. The computer creates a baseline for how you drive and adjusts throttle response accordingly. If you're a gentle driver, it assumes you want gentle inputs. This isn't a conspiracy. It's designed to give you consistent pedal feel as components wear. The proper reset procedure. Turn ignition to on position, don't start engine. Wait 3 seconds. Press accelerator pedal fully to floor for 10 seconds. Turn ignition off with pedal still down. Release pedal and wait 10 seconds. Start engine normally. This works on most 2005 and newer vehicles with electronic throttle control. What actually happens? This clears the learned throttle position values, forcing the ECU to relearn with factory parameters. You'll notice crisper initial throttle response. Realistic expectations: 5 to 10% improvement in throttle response feel. No horsepower gain, but sharper pedal input. Important note: this is in your owner's manual for many vehicles under battery disconnect procedures. It's not hidden, it's just not advertised. Technique number 2, the complete ECU relearn cycle. After any electrical work or battery disconnect, your car runs a bit rough for the first few drives. That's your ECU relearning dozens of parameters. The accelerated relearn process. After battery reconnection, ensure all accessories are off. AC, radio, lights. Turn key to on. Wait 30 seconds. This allows module wake up. Start engine and let idle for exactly 3 minutes untouched. Turn on AC to max for 1 minute to test idle compensation. Turn off AC, idle for another minute. Take a 15-minute drive with varied speeds and gentle acceleration. The science. Your ECU monitors oxygen sensors, throttle position, coolant temp, and dozens of other inputs to build fuel trim tables. This process gives it clean data. When to do this? After battery replacement, after spark plug changes, after MAF or O2 sensor replacement, when you notice rough idle after service. This procedure is free, takes 20 minutes, and replaces what dealers charge $150 to $200 under the name ECU reprogramming. Sensor maintenance. Your engine relies on a network of sensors feeding real-time data to the computer. When these get dirty, and they will, your engine's efficiency drops. Let's clean them the right way. Technique number 3, mass airflow sensor cleaning. This sensor measures exactly how much air enters your engine. It's incredibly sensitive, a tiny hot wire that air flows across. The computer uses this data to calculate perfect fuel mixture. Why it matters? Even microscopic contamination changes the sensor reading. Your engine might be getting 200 grams of air per second, but a dirty sensor reports 180 grams. The computer then underfuels, causing rough running and loss of power. Proper cleaning procedure. Locate MAF sensor, usually an air intake tube between filter and throttle. Disconnect electrical connector. Remove sensor, usually 2 bolts or clips. Use only CRC MAF sensor cleaner or equivalent. Never use brake cleaner, carb cleaner, or contact cleaner. These leave residue that damages the sensor. Spray from 6 to 8 inches away in short bursts. Let air dry for 10 minutes. Never blow with compressed air. Reinstall and reconnect. Never touch the sensor element. Oils from skin cause damage. Expected results: smoother idle within the first minute. Restored fuel economy, typically 1 to 3 mpg on contaminated sensors. Better throttle response. Possible check engine light resolution for lean or rich codes. Clean this every 30,000 miles or when you notice decreased fuel economy. The cleaner costs $8 to $12 and takes 15 minutes versus a $180 to $250 sensor replacement at the dealer. Technique number 4, oxygen sensor maintenance. Oxygen sensors monitor exhaust gases to fine-tune fuel delivery. Unlike MAF sensors, these operate in 1200-degree exhaust gas and deal with carbon buildup. The truth about O2 sensor cleaning. Most mechanics will tell you O2 sensors can't be cleaned. They're designed to be replaced every 60 to 100,000 miles. But there's a middle ground for sensors showing early contamination. Extended life technique. For sensors showing sluggish response but not failure. Remove sensor. Requires O2 sensor socket, a $15 tool. Visual inspection. If ceramic element is cracked or white, replace it. If coating is black carbon, soak tip in gasoline, not cleaner, for 2 to 4 hours. Gently rinse with fresh gas. Air dry completely, 24 hours minimum. Apply anti-seize to threads included with quality sensors. Reinstall to spec, usually 30 to 33 pound-feet of torque. Work in ventilated area, gasoline vapors are explosive. Realistic expectations. May restore function for 10 to 20,000 miles on contaminated sensors. Won't fix electrically failed sensors. Best for preventative maintenance on higher mileage vehicles. This costs essentially nothing versus $60 to $100 per sensor replacement. Technique number 5, throttle body cleaning. Your throttle body is the gateway for air entering your engine. Over time, blow-by oil vapors from the PCV system coat the inside with sticky carbon deposits. What's really happening? Those deposits act like barnacles on a ship's hull, creating turbulence and restricting airflow. On severe cases, they can affect the throttle blade's ability to close completely, causing high idle. Professional cleaning procedure. Required supplies. Throttle body cleaner, not carb cleaner, clean microfiber towels, a small brush, an old toothbrush works. Gloves. Steps. Remove air intake tube to access throttle body. Do not start engine during cleaning. Spray cleaner on deposits. Gently agitate with brush. Avoid scratching the butterfly valve. Wipe clean with microfiber towel. Repeat until no residue remains. Clean throttle position sensor area carefully. Reinstall air tube. Perform throttle relearn procedure from technique number 1. Never force throttle blade open. This damages the motor. Expected improvements. Smoother idle, especially noticeable on high mileage vehicles. Resolved high idle issues. Slightly improved throttle response. Potential resolution of throttle position sensor codes. Do this every 30 to 50,000 miles depending on driving conditions. Costs $8 to $15 and takes 30 minutes. Intake and combustion optimization. Now we're moving into the engine itself, optimizing how air and fuel mix and burn. Technique number 6, intake valve carbon cleaning. This is especially critical for direct injection engines found in most vehicles 2012 and newer. Unlike older port injection engines, DI engines spray fuel directly into the cylinder, meaning nothing ever washes the intake valves. The carbon accumulation problem. In port injection, fuel sprays on intake valves, keeping them clean. In direct injection, valves never see fuel. PCV oil vapor bakes into carbon. After 50 to 80,000 miles, DI engines can have deposits 3 to 5 millimeters thick on valve backs. This reduces airflow, causes rough idle, and kills power. DIY cleaning method for mechanically inclined. Warning, this requires mechanical skill. If uncomfortable, use professional service. Remove intake manifold to access valves. Rotate engine to close specific valves. Use walnut shell blasting, safer than chemicals for aluminum heads. Manual scraping with plastic tools for stubborn deposits. Vacuum all debris thoroughly. Reassemble with new gaskets. Never use metal tools. Damages valve seating surfaces. The safer alternative, spray method. For those not removing intake manifolds, warm engine to full operating temperature. Remove specific vacuum line or use intake port access. Introduce CRC intake valve cleaner while engine runs at 2000 RPM. Follow product instructions precisely. Expect white smoke from the exhaust. This is normal. Drive for 30 minutes at varied speeds. Results: restored engine smoothness, improved cold start performance, reduced carbon knock, better fuel economy. 1 to 2 mpg typical. Do this every 60 to 80,000 miles for DI engines. DIY costs $15 to $40 versus professional walnut blasting at $300 to $600. Technique number 7, spark plug optimization. Spark plugs are spec'd from the factory, but there's room for optimization based on your specific driving and fuel quality. Understanding spark plug gap. Gap is the distance electricity must jump. Too large, weak spark, possible misfire. Too small, small flame kernel, incomplete combustion. The factory compromise. Manufacturers set gaps for worst-case scenarios. Low quality fuel, neglected maintenance, extreme temperatures. Your gap might be set for 87 octane in Death Valley when you're running 91 octane in Seattle. Smart gap optimization. Before you start, check owner's manual for factory spec. Use proper gapping tool, wire style, not coin style. Adjust only new plugs. For high-quality fuel users who regularly run 91 plus octane, factory spec minus 0.002 to 0.003 inches for stronger spark. Example, 0.040 factory becomes 0.037 optimized. Provide stronger spark energy, especially under load. For economy-focused driving, keep factory spec or increase by 0.002 inches. Larger gap equals larger flame kernel equals more complete burn.
Trade-off, slightly harder on ignition system. Never exceed manufacturer maximum gap spec. Proper gapping technique. Check gap on new plug, often incorrect from factory. Bend ground electrode only, never center electrode. Use gentle pressure, check frequently. Verify with gauge before installation. Apply anti-seize to threads unless pre-applied. Torque to spec, usually 15 to 25 pound-feet. Expected results: crisper throttle response, slightly improved cold start. more consistent idle, modest fuel economy improvement 0.5 to 1 mpg. This is included in regular plug replacement and adds just 5 minutes. Technique number 8, ignition coil optimization. Your ignition coils transform 12 volts from the battery to 40,000 plus volts for the spark plugs. They're designed to last 80 to 120k miles, but performance degrades gradually. Signs of coil degradation, intermittent misfire codes, rough idle when cold, hesitation under load, decreased fuel economy. Testing versus replacing. Before replacing coils blindly, check resistance. Primary 0.4 to 2 ohms, secondary 6,000 to 30,000 ohms. Swap coils between cylinders to see if misfire follows. Inspect for oil contamination or cracks. Resistance specs vary, check service manual. The upgrade opportunity. When replacement time comes, consider OEM plus quality. Look for coils with higher dwell time ratings. Brands like Delphi, Bosch, or NKG often exceed OEM specs. Avoid ultra-cheap coils, they fail quickly. Installation tips. Apply dielectric grease to spark plug boot. Check valve cover gaskets. Oil kills coils. Replace in sets for even performance. Always replace spark plugs simultaneously. Cost $25 to $60 per coil for OEM quality. Fuel system optimization. Your fuel system is a precision delivery network. Let's optimize it safely. Technique number 9. Fuel injector cleaning done right. Fuel injectors are precision nozzles with holes smaller than a human hair. Over time, deposits from fuel varnish and carbon restrict these openings. The spray pattern problem. Clean injector, fine cone-shaped mist. Dirty injector, streams, dribbles, or restricted flow. This affects combustion efficiency, emissions, power delivery, and fuel economy. The 3-tier approach. Tier 1, preventative every 5,000 miles. Add quality fuel system cleaner to tank. Chevron Techron Concentrate, BG44K, Liquid Moly Jectron. Run a full tank through system. This prevents deposits from forming. Tier 2, corrective every 30,000 miles or when symptoms appear. Professional fuel injection service. Fuel rail removed or serviced in place. Injectors cleaned with pressurized solution. Spray patterns tested. Costs $120 to $200 for professional service. Tier 3, replacement 100,000 plus miles or when cleaning fails. Individual injector replacement with updated designs. Never run engines solely on cleaning chemicals. Damages fuel pump. Realistic expectations. Tier 1, maintains performance, prevents issues. Tier 2, restores lost performance, improves fuel economy 2 to 4%. Tier 3, necessary for severely clogged or electrically failed injectors. DIY note, the disconnect fuel line and run on cleaner method is dangerous and can damage fuel pumps. Use professional services for heavy cleaning. Technique number 10, fuel filter service. Modern vehicles have 2 types of fuel filter setups. External, serviceable filters on older vehicles and some trucks, located along fuel line. Replacement interval 20 to 40k miles. Cost $15 to $40. DIY friendly. Internal lifetime filters on most 2010 plus vehicles. Located in fuel tank, designed to last 150,000 plus miles. Replacement requires tank drop, $400 to $700 service. The lifetime filter truth. These are called lifetime not because they last forever, but because they're designed to match transmission and differential service intervals. In clean fuel conditions, they genuinely can last 200k plus miles. When to service, noticeable fuel pressure drop, frequent fuel pump failures, persistent rough running despite other maintenance. The inline filter addition. Some mechanics add an external inline filter as secondary filtration. Pros, extra protection for injectors. Easy to inspect and replace. Catches contaminants before pump. Cons, additional restriction in fuel line, potential installation leak points, unnecessary on vehicles with clean tanks. Recommendation: only add inline filters if you regularly use questionable fuel, have older vehicle with known tank rust, work in agriculture or construction, contaminant-prone environments. Inline filter costs $15 to $35 plus installation. Fuel pressure optimization. Your fuel system operates at precise pressure, typically 40 to 70 psi depending on design. Low pressure causes lean running and hesitation. High pressure wastes fuel and can damage injectors. Testing fuel pressure. Required tool, fuel pressure test kit, $30 to $50. Procedure: connect gauge to fuel rail test port. Turn key to on, don't start. Note pressure reading compared to manufacturer's spec, usually 55 to 65 psi. Start engine and note pressure under idle.
rev engine, and watch for pressure consistency. Spec varies by vehicle, check service manual. Diagnosing pressure issues: low pressure, below spec, clogged fuel filter, weak fuel pump, restricted fuel line, failing pressure regulator. High pressure, above spec, stuck pressure regulator, restricted return line, faulty ECU signal. Pressure that fluctuates, failing fuel pump, electrical connection issues, clogged filter. When to test: before diagnosing bad injectors, when experiencing hesitation, after fuel pump replacement to verify proper operation, during tune-up on high-mileage vehicles. The gauge investment is $30 to $50 and testing takes 15 minutes. Breathing and exhaust: your engine is an air pump. The more efficiently it breathes, the better it runs. Technique number 12, air filter optimization. The air filter debate: paper versus cotton versus foam. Let's cut through the marketing. Paper filters, OEM. Pros: excellent filtration, cheap, no maintenance. Cons: create some restriction, disposable. Cost: $10 to $25. Recommendation: best for most drivers. Cotton gauze filters, K&N style. Pros: reusable, slightly better airflow. Cons: expensive, requires maintenance, and can damage MAF sensors if over-oiled. Cost: $40 to $80 initial, $10 cleaning kit. Recommendation: only for enthusiasts willing to maintain them. Foam filters. Pros: maximum airflow for racing. Cons: poor filtration, not street legal. Recommendation: track use only. The truth about performance air filters: on a properly designed intake system, a clean paper filter flows more than enough air for a stock engine. Even a 300 horsepower engine only needs about 600 CFM airflow. Any quality filter provides this. The real benefit: washable filters save money over time if maintained. Performance gains are typically under 2 to 3 HP, which is imperceptible. Smart air filter maintenance: inspect every 15,000 miles. Replace or clean at 30,000 miles or sooner in dusty conditions. Never over-oil cotton filters, causes MAF sensor contamination. Ensure proper seal in airbox. Unfiltered air causes engine damage. Never run without air filter, 1 minute causes permanent engine damage. Technique number 13, intake system inspection. Beyond the air filter, your entire intake system should be airtight and unrestricted. Common intake problems: cracked intake boots allow unmetered air, cause lean conditions. Loose clamps create vacuum leaks. Collapsed intake tubes restrict airflow. Resonator restrictions: some can be legally modified. Intake inspection routine: visual inspection of all rubber boots. Look for cracks, especially at bends. Check all clamps for tightness. Spray soapy water at connections while engine idles. Bubbles mean leak. Inspect PCV connections, common leak point. Look for oil residue, indicates leak location. Fixing leaks: replace cracked boots, typically $15 to $40 each. Tighten clamps: use worm drive clamps, not spring clamps. Replace brittle vacuum lines. Why this matters: unmetered air from leaks causes rough idle. Check engine lights for lean codes, poor fuel economy, hesitation under load. Expected results after fixing leaks: smooth idle restoration, improved throttle response, better fuel economy, can improve 2 to 5 mpg on severe leaks. Resolve check engine lights. Technique number 14, PCV system maintenance. The positive crankcase ventilation system is one of the most neglected yet important systems. What it does: engines create blow-by gases, combustion pressure that sneaks past piston rings into the crankcase. The PCV system routes these gases back into the intake to be burned, preventing oil contamination, pressure buildup, and harmful emissions. The PCV valve: this simple one-way valve regulates flow. When it sticks open, causes rough idle, oil consumption. Closed, pressure builds, causes leaks at gaskets and seals. Testing your PCV valve: remove valve, usually in valve cover or intake. Shake it, should rattle, confirms internal check ball moves. Blow through in one direction, should flow. Blow through opposite direction, should block. Inspect grommet and hose for cracks. Replace every 30,000 to 60,000 miles. Costs $8 to $25. Advanced PCV maintenance. On high mileage or modified engines, consider an oil catch can. What it does: catches oil vapor before it reaches intake valves. When useful, turbocharged engines, high mileage engines 100K plus, performance applications. Quality units cost $50 to $150. Technique number 15, catalytic converter efficiency. Catalytic converters rarely fail, but they can become less efficient over time. How catalytic converters work: precious metals, platinum, palladium, rhodium, catalyze reactions that convert carbon monoxide into carbon dioxide, nitrogen oxides into N2 and O2, and unburned hydrocarbons into CO2 and H2O. Why efficiency drops: surface contamination. Oil, coolant, or rich fuel conditions coat the catalyst. Thermal degradation. Repeated overheating damages the substrate. Physical damage. Impact or rust perforation. Maintaining converter efficiency. Preventative. Fix oil consumption issues immediately. Maintain proper air-fuel mixture. Avoid prolonged idling. Use quality fuel. Restorative. High-temperature burn-off drives. Catalyst cleaner additives have limited effectiveness. The high-temperature cleaning drive. When to try? Check engine light for catalyst efficiency. Failed emissions test. Marginal failure. No physical converter damage. Procedure. Fill tank with premium fuel. Add bottle of fuel system cleaner. Helps ensure complete combustion. Drive highway speeds 60+ miles per hour for 30 to 45 minutes. Maintain 2500 to 3500 RPM when safe. This heats converter to cleaning temperature over 700 degrees. Let cool completely. Retest. Only attempt if vehicle is in good mechanical condition. Misfires damage converters. Realistic expectations. May restore marginal converters. Won't fix physically damaged converters. Won't fix converters contaminated with coolant or oil. When replacement is necessary. Physical damage, rattling, holes, severe contamination, failed efficiency codes persist after cleaning. Fuel additive costs $15, replacement costs $300 to $2,000 depending on vehicle. Conclusion, we've covered 15 techniques that can genuinely restore and optimize your vehicle's performance. But here's the real secret that beats all of these combined: consistency. The most powerful maintenance secret, it's not a trick or a hack, it's following your manufacturer's maintenance schedule religiously. Here's why. Preventative maintenance, $1,200 per year average. Deferred maintenance, $3,500 plus in repairs every 2 to 3 years. The techniques I've shown you today aren't about gaming the system. They're about understanding your vehicle well enough to maintain it properly between service intervals. Your action plan this month: reset your throttle body adaptation, free, 60 seconds. Inspect and clean your MAF sensor, $10, 15 minutes. Check your air filter, free, 5 minutes. Within 3 months, perform complete intake inspection. Test and replace PCV valve if needed. Clean throttle body. Within 6 months, professional fuel injection service or quality fuel cleaner routine. Spark plug inspection or replacement if due, and review and plan any upcoming maintenance. Remember, your car doesn't need tricks to run well. It needs understanding, consistent maintenance, and respect for engineering. Give it those 3 things and it'll reward you with hundreds of thousands of reliable miles.